Hi, and welcome to section 3.2e. E stands for extension. We're going to be talking about factoring expressions. I'm not really sure why this isn't covered when we talk about the distribution property because they kind of go back and forth. Finding common factors in an expression is actually sort of the reverse of, well, it is the reverse of the distributive property. Ever wonder how when we have 3 times 2x plus 2 and you distribute the 3, you get 6x plus 6. Well, we've talked about the distributive property and how you go from this expression to this expression. Today we're going to talk about how you start with 6x plus 6 and pull 3, which is the common factor. Actually, in this case, the greatest common factor would be 6, but that's a story for later on down the road. So let's delete that, and we will start with the lesson. So one of the things we're going to talk about is prime factorization. So if I have 24 and I want to know what its prime factorization is, well, I would pick any two multiples of 24. We have 2 and 12. 2 is prime, so we stop there. 12 is not. 12 can be 2 and 6. 2 again is prime. 6 is not, which is 2 and 3. Now all of these are prime. So our prime factorization of 24 is equal to 2 times 2 times 2 times 3. That's our prime factorization. We're going to use that to find the greatest common factor of numbers. So let's start out with example 1. And we're going to factor using greatest common factor. So we're going to factor an expression. So we're going to factor an expression. We're going to factor expression using greatest common factor. So our example is factor 24x minus 18 using greatest common factor. So you're going to look for the largest number that divides, into both 24x and 18. So let's find the common factors. So 24 we just did is 2 times 2 times 2 times 3 times x. And 18 is 2 times 3 times 3. So now we can look for the common factors of both. Well, we have 2 2's here and we have 2 3's. So we have a 2 times a 3 is equal to 6. So our greatest common factor in these numbers is 6. So we can rewrite our expression 24x minus 18 as 6 times 4x minus 6 times 3. Because 6 times 4x is 24x and 6 times 3 is 18. Well, now that we've got the 6 in both of these, remember how with the distributive property, we take a number and we apply it to every member of the terms inside of the parentheses. We can take that 6 out. So we can say 6 is on the outside and we're left with 4x, subtract 3. And that is how we factor 2x minus 18 using the greatest common factor. Greatest common factor in this case is 6, so we put 6 on the outside and we're left with 4x, subtract 3. So that's example 1. Let's move on to example 2. Hello, Brenna. Brenna's watching my lesson. So example 2. No, it only works with my fancy pen.
That's stupid.
She's trying to make the little pad thing work with just her finger. It only works with my pen.
That's stupid.
And she's decided that's stupid. So, hello, Brenna. Welcome to 7th grade math. So here we go. So we're going to factor out a fraction. So this is a different factoring. And there's many different kinds of factoring. There's no one specific factoring that you might use. You'll see factor out the greatest common factor. You'll say factor out this term. And factoring is used in a lot of different applications. At this point, it's hard to say it'll be used always for this kind of thing. Very often you'll see factoring used when you're trying to simplify very complex equations or expressions. So we're going to factor out a fraction. So we're going to start with, we're going to factor 1/2 out of 1/2 x plus 3/2. Before, we used to look at we would take the factors of each of the terms and figure out what the greatest one was. Well, we really already know what we want to factor out. So we're going to say 1/2 x is equal to 1/2, because that's the part we want to factor out. So if we took 1/2 out of here, we'd be left with x. So 1/2 times x is equal to 1/2 x. Now 3/2 is a little bit more complicated. We're still taking out the 1/2 because we've already decided that we're factoring out 1/2. So we have to say, what times 1/2 would equal 3/2? Well, if we just multiply across, we're missing 3. 3 times 1 is 3, and the bottom we're missing 1. So it would be 3. So this is our common factor. And so we would rewrite 1/2 x plus 3/2. If we took out the 1/2, we'd be left with x. If we took 1/2 out of here, we would be left with 3. And if you checked this and said 1/2 times x would be 1/2 x, which is that, 1/2 times 3 would be 3/2. So it checks out and works good. All right, let's try one more example. So example, help if I spelled example correctly, example 3. It's factoring out a negative number. So factoring out a negative number. All right, we're going to factor -2 out of -4p plus 10. Okay, so we're going to say -4p into each of the terms. And that is equal to -2, because that's what we want to factor out, times 2p. Well, 10's a little bit more complicated. We have 10, and we want to factor out a -2. What we have to say is, what times -2 is equal to 10? Well, since 10 is a positive, and that's a negative, we have to say that it is probably negative. It has to be a negative number. And then 5 times 2 is 10. So negative times negative is a positive. So now that we know that the common, that we're factoring out the -2, we can say -4p plus 10. We're putting -2 on the outside. And if we divide -4p by -2, we are left with 2p. So 2p. And if we factor out -2 out of 10, we're left with a -5. And of course, we mathematicians prefer to write this so that it looks like this, 2p subtract 5. And that's how you factor out a negative number. The key is figuring out what times the thing that you want to factor out is equal to the original term. And that's how you factor. Good luck with the homework. I'll see you tomorrow in class.